In this lesson, Patterns, Equations, and Graphs, we're going to continue our look at basic information about equations and different ways of expressing them in mathematics and in relation to the world around us. So the first thing is a two-variable solution. We know that from equations, the solution to an equation is the value for the variable that makes the statement true. Well, when you're dealing with an equation that has two variables, such as x and y, the solution, or a solution to that equation, is any pair of numbers that will make the equation true. For instance, in this situation, we have the equation y equals 3x minus 5. From previous math courses, you should be aware that when you are given a coordinate, the items inside of the ordered pair are given as xy portions. So if we look at this first equation, or this first coordinate, 2, 6, do the items 2 and 6, as x and y respectively, satisfy this equation of y equals 3x minus 5? Well, the way we check this is we substitute the values in. So where I see the y, I'm going to replace it with a 6, and I want to know, does that equal 3 times 2 minus 5? Well, the left-hand side is already simplified, it's 6. The right-hand side, 3 times 2 is 6. We subtract 5. We end up with 6 equals 1, which is not true. So no, this is not a solution to this equation of two variables. Trying our next one, 8, 19. I substitute the 19 in for y, and that's supposed to equal 3 times 8 minus 5. Now, 3 times 8 is equal to 24. 24 minus 5 is 19. So does this satisfy the equation? And that answer is yes. So 819 is a solution to this equation. But we have other points, and it is possible with different values for the given variables that there are multiple answers. Let's continue moving clockwise around the circle. 0, 3. So is 3 equal to 3 times 0 minus 5? So we get 3. I want to know if that's equal to 0 minus 5. 3, in fact, does not equal negative 5. So no, this is not a solution. Our last one, negative 1, negative 8. We want to know, does negative 8 equal 3 times negative 1 minus 5? Well, negative 8, is that equal? 3 times negative 1 is negative 3. Minus 5 is, in fact, negative 8. So yes, this also is a solution to this equation. So when we have x and y related as such, it is possible to have an infinite number of items that would satisfy it. We just have to find items that work, and we know if they work or not by substituting them into the original equation for their proper items. So if we're given an equation, we can tell if items satisfy it, but how do we develop equations in the beginning? And to study that question, we're going to talk about what I call GETS, or graph, equation, table, story. Any situation that we have, we should be able to describe in some way, or represent in some way, all four of these methods. So here we have a story. Two cousins, Becca and Tori, share the same birthday, but Becca is 4 years older. Express Becca's age based on Tori's. When we have equations that are centered around two variables, it's often accepted that one variable is what we call independent and the other is dependent. And we'll speak about these terms in later lessons. But basically what it comes up to is that one item controls the other. Since we're supposed to be expressing Becca's age in terms of Tori's, we're going to assign Becca as the dependent and Tori as the independent. So Becca I'm going to have be the variable y and Tori as the variable x. Now we know that Becca is 4 years older than Tori, so that would mean that y equals Tori's age, x, but Becca's 4 years older, so I get plus 4. So we have a story, we have an equation, so looking at our gets up here, story, equation. Now we need a graph and we need a table. So for the table, what I will do is make a little t-chart, x and y, and I will select certain values for x and figure out what y is. When Tori was 1, how old would Becca have been? What about at the age of 14? How old is Becca? And when Tori reaches retirement age, currently accepted as 65 years old, how old will Becca be? Well, if we substitute these numbers in turn, so if I take my 1, substitute in for x, 1 plus 4 is 5. So when Tori had her first birthday, Becca had her 5th. What about 14? Again, substituting in, 14 plus 4 is 18. So when Tori turned 14, Becca turned 18. And again, the retirement age of 65. If we substitute the 65 in for x, 65 plus 4 is 69, would tell the age of these two cousins at the latter parts of their lives. So that takes care of our table. Now, what does a graph look like for this? Well, a graph, we establish a set of axes, numbers to operate by. I'm just putting on a couple of values here. The horizontal axis is the x-axis and the vertical is the y. And numbering both of them according to a scale established. And now we're going to work our way through. We can use 1 point from off of our table. We had the coordinate 1, 5 on here. So we go 1 on x and 5 on y. And we have a point right there. What if x had been 0? What is 0 plus 4? That, of course, is 4, which indicates that when Tori was born, Becca had her 4th birthday. 2 points are sufficient to establish a line, but just to do another, we'll extend our axis up here to 6. When Tori is 2, we substitute 2 in for x. 2 plus 4 would give us 6, and we end up with a point here. And we can connect these points indefinitely. So now we have a story, an equation, a table, and a graph. Each of these have their own benefits, and each of them have their own downfalls. But there are multiple ways of representing the same information. So let's practice with this a little bit. So I have an equation here. Y equals 3x minus 4. What could we do with this? Well, we have our equation. Let's take a look at what a table would be like. So x and y, 0, 1, 2, and 3 are my values. Substituting them in, 0, 3 times 0 is 0, minus 4 is negative 4. Next, substitute in the 1, 3 times 1 is 3, minus 4 is negative 1. 2, 3 times 2 is 6, minus 4 is 2. And lastly, 3 times 3 is 9, minus 4 is 5. Now if we were to graph this, we could establish our axes again. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3. And 1, 2, 3, 4, just based on the area that I have. So plotting points, 0, negative 4, 1, negative 1, 2, 2, then 3, 5 is off the chart, but we have this graph. So what could this represent? Well, let's say that Tom goes out for a walk at the track, and it's a long track, not a running track, but a long distance track or circuit, and every hour he makes 3 laps. So our x would be the number of hours, and he's doing 3 laps. Well, after he's done 4 laps, Bill joins him. So we could be expressing Bill's laps in terms of Tom's and have the information given. Let's take a look at the next one. We have a table established, x and y. The coordinates 0, 3, 1, 5, 2, 7, and 3, 9. We can write an equation, but we'll get to that at a later point in our study of Algebra 1. Plotting the points on a graph, we have 1, 2, 3, 4, 5, 6, and we'll count these out by 2's, so that's actually 12, 6 is there. And on my horizontal axis, 1, 2, 3, 4, I can count by 1's. Good thing to remember that the two axes don't always have to be counting by the same thing, but in any direction, they do need to count the same for them. And then I go to plot my points, so I have 0, 3, which would be right there, 1, 5, 2, 7, and 3, 9, and we end up with this line. Then developing a story about it. It could be anything, so be creative and use your imagination. But the thing is, when we have 2 variables, there's a lot of ways of representing. There's the equations for the logical learners, there's the graphs for the visual, there's the stories for the creative, there's the tables for the organizational types. So look at opportunities to express items in all these different forms, and you'll do a lot better as we move forward throughout our study of Algebra 1.